This example explains the calculation of uniformly distributed load, dead load G, to be supported by the steel beam A. So we have a steel beam A. So we need to find the uniformly distributed load on the steel beam, which has a self weight of 0.4 kilonewtons. So here this steel beam is carrying the weight of this concrete slab, reinforced concrete slab, which is 125 millimeter thick, and it has a terrazzo paving which is 16 millimeters thick. It's just a kind of tiles that we use to cover the slab. So it's kind of tiles, so which is 16 millimeters thick. Now what we need to do it, we need to find how much uniformly distributed load is applied due to this paving, due to this slab, and due to this steel beam. So we are dividing this portion into three. First we will calculate the dead weight, dead load applied due to the self weight of the steel beams. Then we will calculate the paving, how much load due to the weight of this paving, and then we calculate the concrete weight. Now the first one that we like to calculate is the self weight of the beam, which is 0.4 kilonewton per meters, and that is given in the questions. If I can show it here, which is given in the questions, 0.4 kilonewton per meter. So it's quite easy here that due to the self weight of the actual steel beam, it has a uniformly distributed load of 0.4 kilonewton per meter. So if I can show this one into the three-dimensional pictures here, I can explain it here, like if I have three-dimensional picture of the self weight of, so if I just draw the individual steel beams here, and this individual steel beam has a self weight, so the weight of this one create the uniformly distributed load on the beam, so that is 0.4 kilonewton per meter. So that is the first one that we. Now the second case that we like to calculate is the self weight of the paving. So if I can show it in the questions, this paving has a 16 millimeter thick. So now first of all, we did not given any pressure for this paving, so we can use table A2 on page number 20. I can show it in the Australian standard. So if you check the Australian standard, AS NZS 1170.1 2002, we can find that the terrazzo paving 16 millimeter thick has a pressure of 0.43 kilonewton per meter. So in this case we have a 0.42 that is coming 0.43 that is coming from the Australian standard kilonewton per meter square. That is just, I explain it here, 0.43 for 16 millimeter thick. So that is 0.43 for 16 millimeter thick. So if I just want to calculate the dead load due to this paving, so we have a equation, pressure times the perpendicular length. I think that pressure is 0.43. Now we have a pressure times perpendicular length, which is 0.43 times 3.3. Now the concept to get the 3.3 length. Now these steel beams has load shared by these steel beams, and this is internal steel beam. So in that case, only half of this side and half of this side would be carried by the middle steel beam. So this length would be 1.8 meters, which is half of this 3.6 meters, and this length is 1.5 meters, which is half of 3 meters. So the total length for these steel beams we can have a 3.3, which is 1.8 plus 1.5. So the perpendicular length is 3.3. So 0.43 times, if I do the quick calculation here, which is 0.43 times 3.3, it gives us, instead of this one, is 1.42 kilonewton per meters. It's a small change here. Now the last one, if I show it in the three-dimensional view, that for this for this paving. Case of paving, it has a steel beams. So this paving has a weight of as you know, the weight of 0.43 kilonewton per meter square. So that is the pressure. You can say that is the pressure, 0.43 kilonewton per meter square. That is from the Australian standard for 16 millimeter thick paving. Now if I like to convert this pressure into UDL load, which is acting on these steel beams, we need this perpendicular length, and this perpendicular length is the half on the left side, half on the right side, which is 1.8 and 1.5. You can check the questions. That will give us 3.3 meters. So that's the length, 3.3 meters. So the last one is the reinforced concrete slab, which has a density in kilonewton per meters times the area. Now the density has given in the table number A1 at page number 19, where we have a concrete dense aggregate unreinforced. If it is unreinforced concrete, we have 24 kilonewton per meter cube, but we have a reinforcement, so we need to add 0.6 into 24, which is 24.6. So that is 24.6 kilonewton per meter cube density of the reinforced concrete slab times the area, 3.3 times 125. So that's concept. That is pretty much same thing. That is, if I can draw this slab here, and we have a length of 3.3 meters, and then we have a thickness of 125 millimeters, or say 0.125 meters. So we are just looking for the UDL load acting due to these slabs, and that UDL load can be calculated by multiplying the density times the perpendicular area. So we are not taking this area because this is the parallel to the loading. We are just taking the perpendicular area. So that's the concept, 3.3 times 125. So that gives us 10.15. So total dead load on the steel beam A is 0.4, which is we calculated in the just previous step, 0.4 kilonewton per meter, which is self weight of the beam, and then 1.24 kilonewton per meter, which is the paving self weight. So that's paving self weight we calculated here, which is pressure times perpendicular distance, and we got 1.42, and that's last one is 10.15 kilonewton per meters. So if we add them all, if the final answers, that is 11.97 kilonewton per meter. So actually that's final answer saying that these steel beams would have a UDL. So if I just draw the steel beam here as a just a demonstration, this steel beam has this self weight has a UDL load of 10. That self weight has a 11.97 kilonewton per meter. That's due to the weight of the his own own beam, concrete and paving. That's the quick video on the example 3. Thank you very much.